Section: Introduction. In this section, we discuss the importance of evaluation in tracking progress in the machine learning and language modeling communities. Evaluating models on shared benchmark tasks helps demonstrate improvements over existing methods and guides the direction of future research. However, transparent and reproducible evaluation of large language models is challenging. We have faced difficulties in reproducing results from various papers and conducting new evaluations ourselves. To address this issue, we created the Language Model Evaluation Harness, lm-eval, a flexible evaluation library that serves as research infrastructure. Our aim with lm-eval is to make it easy for researchers to run any benchmark on any model and for creators of new model inference libraries or evaluation benchmarks to connect their work to the broader ecosystem. Over the years, we have refined lm-eval based on feedback from the open source community and our evolving understanding of best practices for language model evaluation. One major challenge in evaluating language models is the key problem, where determining if two sentences convey the same meaning despite using different words is difficult. Human annotators could solve this, but it is costly and not always feasible. Automated metrics like Blue and Rouge offer a more cost-effective solution but have their limitations. Model-based metrics have also gained traction but come with their own set of challenges. Another challenge lies in benchmark design and validity. The goal is not just to obtain a numerical score but to ensure that the benchmark reflects real-world scenarios accurately. While validity remains a concern, our focus with lm-eval is on ensuring consistent measurements across different runs and models, prioritizing research infrastructure over benchmark preferences. Section Summary. In this section, we address the challenges in evaluating language models, particularly focusing on the key problem of assessing semantic equivalence in different ways of expressing ideas. We discuss the limitations of relying solely on human annotators due to cost and potential biases, leading to the use of automated metrics like Blue and Rouge, despite their flaws. Additionally, we highlight the importance of benchmark design to ensure that evaluations serve as reliable proxies for real-world phenomena, emphasizing the need for consistency in measurements across different models and runs. Section: Implementation Difficulties and Reproducibility. In this section, we discuss the challenges we face when implementing benchmarks in machine learning research. Once a benchmark is created, researchers worldwide need to implement it consistently to ensure fair comparisons of model evaluations. However, adapting benchmarks to different workflows and libraries can lead to inconsistencies and difficulties in drawing conclusions across various implementations. We emphasize the significance of interoperability and reproducibility in language model research. Even minor variations in prompts, formatting, or implementation details can greatly impact evaluation outcomes. Without access to the original evaluation code, it becomes nearly impossible to account for all subtle details that influence results. This lack of consistency makes it challenging to ensure fair comparisons across different works, even when using the same benchmark. Furthermore, determining how to make fair comparisons across different models and methods remains a complex issue in language modeling. Differences in prompt formats tailored to specific models can inherently change evaluation tasks' difficulty. Additionally, setting up controlled experiments raises questions about normalizing performance based on parameters, training flops, or inference costs. These considerations can significantly affect research findings and must be carefully addressed. Moreover, comparing results with prior work poses challenges due to inaccessible or modified language models developed by industrial labs. The evolving nature of NLP research and the lack of standardized evaluation methodologies further complicate comparisons. Additionally, the rapid pace of change in the field means that many existing benchmarks may not align with current language model training practices, leading to potential validity and difficulty issues. In summary, implementing benchmarks consistently, ensuring reproducibility, and addressing challenges in fair comparisons are crucial aspects of language model research that require careful consideration and standardized practices to drive progress in the field. Section Summary. In this section, we discuss the challenges related to implementing benchmarks consistently across different machine learning researchers, which can lead to inconsistencies and difficulties in drawing fair comparisons. The sensitivity of language models to minor implementation details underscores the importance of full reproducibility and interoperability to ensure accurate evaluations. Additionally, the lack of agreement on how to make fair comparisons across models and methods, along with barriers hindering comparisons with prior work, highlights the complexities and evolving nature of language model evaluation benchmarks in the fast-changing landscape of NLP research. Section: Best Practices for Language Model Evaluation. In this section, we discuss best practices for evaluating language models. Evaluating language models can be challenging due to various obstacles, but there are ways to enhance current practices. We offer our recommendations on how to improve evaluation processes and briefly explain the reasons behind each recommendation. It is crucial to share the exact prompts and code used for evaluation to ensure reproducibility. Using the same set of prompts for evaluating different models is essential for fair comparisons unless there is a valid reason to use different prompts. Prompt engineering should be transparent, and any optimization specific to a particular model should be disclosed. Avoiding the direct replication of results from other studies is important because experimental differences, such as prompts, sample sizes, and metric calculations, can lead to misleading comparisons. If it is necessary to replicate results from other papers, it should be clearly stated and handled with caution. Providing model outputs along with evaluation code enables others to verify scores, conduct statistical tests, and explore different evaluation metrics. Sharing outputs is particularly beneficial for researchers who may not have access to extensive computational resources. Before conducting large-scale evaluations, it is advisable to perform qualitative analyses on a small set of results to identify and rectify any potential issues in the generation code. Qualitative error analysis is essential for understanding why a model performs well or poorly and can reveal errors that may require post-processing adjustments. It is uncommon for language modeling studies to include statistical significance testing, which can undermine result confidence. Reporting results from multiple random seeds can enhance result validity. Statistical analysis, such as averaging model runs or few-shot examples, can help estimate the expected variation across different model training runs. Our language model evaluation tool, lm-eval, is designed to simplify the evaluation process by allowing users to select tasks and use cases according to their preferences. The tool aims to streamline LM evaluations by providing a unified platform for running methods and baselines on various tasks in a controlled manner. We incorporate best practices into the tool's functionality to guide users towards optimal evaluation practices. lm-eval is structured around two main components: evaluation tasks and integrations with new LM implementations. Tasks are implemented as modular units using a common API, enabling easy extension, sharing, and reproducibility among users. Users can define tasks through YAML configuration files or by customizing the task class with specific code. We offer various task implementations and welcome contributions from the community to expand the task library. Our goal is to align with the original benchmark dataset methodologies and adapt tasks to fit prompted evaluation standards where applicable. Section Summary. In this section, we outline best practices for evaluating language models, emphasizing the importance of sharing evaluation prompts and code for reproducibility. We stress the significance of qualitative analysis alongside quantitative scores to identify and rectify potential errors in model performance. Additionally, we introduce lm-eval, a tool designed to streamline language model evaluations by providing a standardized framework for tasks and model integrations, promoting best practices in evaluation methodologies. Section: LMs. In this section, we discuss the LM API, which is a crucial component of lm-eval. Our main aim is to facilitate effective orchestration by allowing various software libraries or autoregressive language model architectures to expand a provided interface for LM objects. To simplify usage and separate model definition and external library integrations from core evaluation logic, we assume that LMs work on dispatched requests. These requests map string inputs to output strings or probabilities. We abstract tokenizers within the LM class and consider a neural language model along with its tokenizer as a unified system under evaluation. LMs follow a straightforward interface with different types of requests to support various tasks within the library. We enable three core types of requests for language models: conditional, log likelihoods, perplexities, and generation. These requests help measure a model's response or latent capabilities in different scenarios. By implementing these fundamental operations, we can evaluate LMs using common approaches found in the literature. While these approaches are standard, they involve many subtle implementation decisions often not fully disclosed in papers. Therefore, we provide a comprehensive description of common implementation details in our approach and others in the appendix to contribute valuable insights to the literature. We also address challenges and incorporate best practices in lm-eval to foster a more robust evaluation environment. For reproducibility, lm-eval promotes standardized task implementations, allowing researchers to report results consistently and track any modifications made to tasks. This ensures that future studies can reproduce reported results accurately. Additionally, we support qualitative analysis by enabling limited sample usage and per-sample logging for error analysis. lm-eval also reports standard errors for most metrics, aiding practitioners in adding statistical measures like confidence intervals to their results. Furthermore, we showcase lm-eval's effectiveness through case studies demonstrating improved evaluation rigor and comprehension. One notable case study involves the Big Science Workshop, where the prompt source library was integrated into lm-eval to facilitate evaluation across various prompt templates. This feature has been widely adopted, emphasizing the importance of considering prompts in the evaluation process. We encourage future research to focus on realistic prompts and explore prompting as a crucial aspect of human-computer interaction. Section Summary. In this section, we introduce the LM API within lm-eval, which allows for the extension of language model architectures through a provided interface for LM objects, enabling the evaluation of models based on dispatched requests. These requests include three core types: conditional, log likelihoods, perplexities, and generation, which cover common evaluation methods used in the literature. Additionally, lm-eval addresses challenges in LM evaluation by promoting reproducibility through standardized tasks, supporting qualitative analysis, and reporting standard errors for metrics to encourage statistical testing and improve evaluation rigor. Section: Difficulties in comparing scores across evaluation setups. In this section, we discuss the challenges we face when comparing scores across different evaluation setups. We acknowledge that the way evaluations are carried out can greatly impact the scores obtained. To illustrate this sensitivity to variations in evaluation methods, we delve into an example and demonstrate how lm-eval can help enhance confidence in comparing scores across different models by addressing these variations. We specifically focus on two well-known language modeling benchmarks: the ARC question answering benchmark and MMLU. The ARC benchmark was modified to an in-context learning setting where the model is presented with a close task, while MMLU provides the model with questions and multiple-choice answers labeled A, B, C, or D. It is important to note that not all research papers evaluate models on these tasks in the same manner as the original formats, which can lead to unreliable comparisons of model performance. By comparing evaluation results on the challenge subset of ARC using different prompts and scoring styles, such as the close style and the MMLU style, we highlight how models can exhibit varying performance levels based on the evaluation setup. It is crucial for model creators to disclose their evaluation settings to ensure meaningful comparisons between different models. Simply copying numbers from other papers without understanding the evaluation setup can lead to misleading conclusions. Furthermore, while statistical reporting like confidence intervals can provide insights into the reliability of measurements, it does not address the variability in model performance across different evaluation settings. This emphasizes the importance of transparently sharing evaluation setups to ensure the credibility of model performance comparisons. We believe that the use of lm-eval can enhance the rigor and confidence in novel evaluation results, empowering benchmark creators and language modeling evaluation research. By providing a configurable evaluation orchestration library, lm-eval facilitates experimentation on LM evaluation complexities, exploration of prompting effects on model performance, and investigation of evaluation methodologies. This tool has been embraced by the community for designing new benchmarks and streamlining the evaluation process, ultimately fostering collaboration and innovation in the language modeling field.